We are starting with exercise number 3 of permutation and combinations. Okay. And in this particular exercise, the most important thing is the formula NPR. Okay. So NPR formula n factorial upon n minus r factorial. Fine. Exercise number 3. Question number 1. So it's a proof problem. Sub question 1. Left hand side 10p3. So this is 10 factorial upon 10 minus 3 factorial. So 10 factorial upon 7 factorial. So 10 into 9 into 8 into 7 factorial. I'll stop at 7 factorial because 7 factorial is there in the denominator. So this gets cancelled. So it is 10 into 9 into 8, which is equal to 720. Okay. Right hand side 9p3 plus 3 into 9p2. Okay. So 9p3 is 9 factorial. 9 minus 3 factorial. 3 into 9 factorial. 9 minus 2 factorial. So 9 factorial upon 6 factorial. 3 into 9 factorial upon 7 factorial. Okay, so 9 I'll reduce it up to 6, and here 9 I'll reduce it up to 7. So 9, 8, 7, 6 factorial, 3 into 9, 8 and 7 factorial upon 7 factorial. Okay, so this is getting cancelled. So 9 into 8 is common. Okay, so within the bracket, we'll just write 7 plus 3. So this is 72 into 10, which is equal to 720. Hence LHS equal to RHS. Okay. One sub question 2. Left hand side npn. So n factorial upon n minus n factorial, which is equal to n factorial upon 0 factorial, n factorial upon 1, which is n factorial. Right hand side 2 into npn minus 2. So 2 into n factorial, n minus 2 factorial. So this round bracket is important, otherwise, mistakes will occur. There is a minus sign, so a bracket. So n and n is gone. So 2 factorial. Okay. Minus minus is plus, so that is equal to 2 factorial within the box bracket. So 2 into n factorial, and this 2 factorial will be 2. So this and this is getting cancelled. So LHS equal to RHS. Okay. Third one. One sub question 3. LHS Pn comma n, which is equal to npn. Okay. It's like the previous part LHS, which is n factorial. RHS Pn comma n minus 1. So it is npn minus 1. N factorial upon n minus, again a round bracket because there is a minus sign, n factorial. Okay. N minus 1, sorry. So n and n will go. 1 factorial is 1. So this is equal to n factorial. Okay. Question number 2, you can solve on your own. Question number 2. Okay. I'll just guide you on one of the problems of question number 2. I'll take question number 2, sub question 5. So a ratio is given. Pn minus 1 comma 3 is to P n plus 1 comma 3. equal to 5:12 n minus 1 P3 divided by n plus 1 P3 equal to 5 upon 12 equal to 5 upon 12 n minus 1 factorial n minus 1 3 factorial divided by n plus 1 factorial n plus 1 minus 3 factorial equal to 5 by 12. So this is going to become n minus 4 factorial. Okay, and this is going to become n minus 2 factorial. Okay, so n minus 1 upon factorial upon n minus 4 factorial. Okay, divided by n plus 1 factorial upon n minus 2 factorial equal to 5 by 12. Okay, n minus 1 factorial n minus 4 factorial into n minus 2 factorial n plus 1 factorial equal to 5 by 12. Okay, so I'll group this term and this term. Okay, and I'll group this term and this term, right? So n minus 1 factorial upon n minus n plus 1 factorial into n minus 2 factorial n minus 4 factorial equal to 5 by 12. So out of these two terms, which is the bigger term? Obviously, it is n minus 1, n plus 1. Okay, you can take the value of n as 10 and then proceed. So this is going to be 11 and this is going to be 9. So n plus 1 is the bigger term. So reduce the bigger term. The first term of n plus 1 is n plus 1. Then n plus 1 minus 1. I cannot stop over here because I did not get n minus 1. Okay, so n plus 1 minus 2 factorial. Okay, upon, sorry, in the numerator it is n minus 1 factorial. So now we can cancel this term and this term because both are n minus 1 factorial. Now out of these two terms, okay, n minus 2 is the bigger term because if n is 10, n minus 2 is 8 and n minus 4 is 6. So n minus 2, n minus 2 minus 1, n minus 2 minus 2 factorial upon n minus 4 factorial 5 by 12. Okay. So here also n minus 4 factor, n minus 4 factor is getting cancelled. Okay. Now we are left with only these brackets. So it is going to be n minus 2, n minus 3 upon n plus 1 into n is equal to 5 by 2, 5 by 12. Now what you are supposed to do, you are supposed to multiply the terms over here, cross multiply with 5 and 12 and solve, get a quadratic and solve. Mostly you'll get a quadratic. Okay. And you may discard the negative value because n is the number of objects in this particular chapter. So you know, no need of this the negative value of n or decimal value of n. So I've given you the guideline what to do after this. Okay, you may solve and proceed. Next one, let's go to question number 3. 6 candidates are called for interview to fill some vacant post in an office. Assuming that each candidate is fit for each post, determine the number of ways in which 2 posts can be filled. Okay. Now first part, 6P2. See, the post cannot be repeated by a candidate. Okay. One post will be given to one candidate only. Okay, so the total number of objects are 6 and total number of posts are 2. So 6p2. Okay, otherwise box method, post number 1 and 2. First post can be filled up in 6 ways or occupied in 6 ways. There are 6 options. Second one will be by 5 ways because one person is already getting one post. So second post will be given to anyone out of 5. Second one, 3 posts. So it is 6p3. Okay. Third one, 4 posts, 6p4. This is how you can solve. Okay. Question number 4. How many 3 digits number can be formed using the digits 1 to 9? This is the object list. No digit is repeated. So 3 digit number 1, 2, and 3. So this can be filled up in 9 ways. This is in 8 ways, and this is in 7 ways. So total will be 9 into 8 into 7. Okay. Or you can also do, there are 9 objects because there are 9 digits and 3 places. So 9p3. Second case, since repetition is there, I will not use the formula. Okay. So this also is 9 ways, this also is 9 ways, and this also is 9 ways. So 9 into 9 into 9, 729 ways. So whenever repetition is there, objects are getting repeated, avoid the formula. Okay. Right. Let's go to question number 5. In how many ways can 6 women draw water from 6 taps if no tap remains unused? Okay. So I'll make you understand using box method. First, 1, 2, 3, 4, 5, 6. So first tap, 6 women can, there are 6 options to use the first tap. Second tap will be utilized by 5, any one of the 5. This will be 4, 3, 2, and 1. So you can multiply all this, or you can simply do 6p6, which is equal to 6 factorial ways. Okay, both the methods are applicable over here. Formula method as well as box method. 7 candidates are 5. This was 5 sub question 1. Let's go to 5 sub question 2. 7 candidates are contesting an election. In how many ways their names can be listed on a ballot paper? Ballot paper is a piece of paper in which the listing of names is done. So first name can be filled up in 7 ways because there are 7 candidates. Second name can be filled up in 6 ways. Any one of the 6 names you can put over here. This will be 5, 4, 3, 2, 1. So you can multiply all this, or you can simply use, there are 7 objects and 7 places. 7 objects and 7 places. So 7 to 7, 7 factorial. Any one of the method is applicable. Okay, let's go to question number 6. Form a committee of 8 persons. Okay. From a committee of 8 persons, in how many ways you can choose a chairman? In how many ways you can? Just a second. Yeah. In how many ways you can choose a chairman and a vice chairman, assuming that one cannot hold more than one position. So as I can see, there is no arrangement over here. It's pure combination problem. It's selection problem. Okay. One second. Basically, I evaluated the question once again. These are two different positions. These are not like a single position, or they're not selecting any two persons from eight. These are two different positions, chairman and vice chairman. Okay, so we are having a chairman, we are having a vice chairman. Chairman can be selected in 8 ways because there are 8 persons. A vice chairman can be selected in 7 ways because one chairman is already selected. Okay, so it is 8 into 7, or you can also do 8p2 because there are 8 persons and two positions. So 6 of question 1 is done. 8 into 7 or 8p2. 6 of question 2. Let us understand. There are 12 persons. In how many ways can we choose? A president, vice president, secretary, treasurer, assuming that each of the 12 persons can hold any office and no person can hold. So repetition is not allowed. So you can directly do 12p. How many positions are there? 1, 2, 3, and 4. 24. Okay, because see, we need a president, we need a vice president, we need a secretary, we need a treasurer. So 12 persons are there for president post. Okay, here it will be 11, here it will be 10, here it will be 9. Okay, so either you can do 12p4 or 12 into 11 into 10 into 9 by box method. Okay, question number 7, sub question 1, you can do it in the last exercise, exercise number 9. Okay, don't do it right now. 7, sub question 2. There are 8 true or false statements in a question paper. How many sequence of answers are possible? Okay, so question number 1, two answers are possible. And question number 2, two answers are possible. Okay, and question number 3, again two answers are possible, true or false. Okay, so there are 8 questions like this. So question number 1, two options are possible, 2, 2, 2 into 2. So this is 2 raised to 8 times. Okay, because there are 8 questions. I've just shown for 3 questions, but then there are 8 questions and there is and in between. Okay. Next one, question number 8. In how many ways 3 different rings can be worn in 4 fingers with at most 1 in each finger? So that means a finger can have only 1 ring or 0 rings, at most 1. It cannot have more than 1 rings. Okay, a particular finger. Okay, so ring number 1 can be worn in 4 ways because there are 4 fingers, and ring number 2 3 ways because 1 finger is already occupied. So now there are only 3 options. And ring number 3 2 ways, and ring number 4 1 way. So it is 4 3 2 1. 4 3 2 and 1. Okay. Yeah. So you can multiply this and get the answer. Question number 9 sub question 1. 9 sub question 1. Okay. In how many ways can 7 books be arranged on a shelf if there is no restriction? So this is pure arrangement. 7 books and 7 places. 7p7, 7 factorial ways. You can also use the box method. Okay. Second one. Second one is quite tricky. Okay. 3 particular books are always together. So let us say B1, B2, and B3 are always together. So this is one object. First object, because they are always together. Remaining objects B4, B5, B6, B7. So these are remaining objects. Total objects 1 plus 1, 2, 3, 4. 5 objects. So 5 objects require 5 places to arrange. Total places R is equal to 5. So NPR 5p5, 5 factorial ways. Okay. Now within the first object, it is not always going to be B1, B2, B3. It can be B2, B3, B1 also. Okay, the arrangement can be anything. So there are 3 objects and 3 places. So NPR, which is equal to 3 factorial, because it is 3p3. Okay, so final answer will be 5 factorial into 3 factorial. The total arrangements into and the arrangements within the first object. So that will be your answer. Question number 9, sub question 3. So now there are 7 books. Okay, 1, 2, 3, 4, 5, 6, 7. Okay. Now, for example, 2 particular books must occupy the ends. So B1 and B2 can always be over here. Okay. So this is case 1 and case 2. We'll just reverse it. It can be B2 and B1 also, like this. Okay. But then these 2 books are specifically at the ends. Okay. So in between there are 5 places, 5 blanks, and number of objects are also 5. Okay. The other books which are left. So NPR 5p5, 5 factorial ways, and here also it will be 5 factorial ways. Okay. So the final answer will be case 1 or case 2. So you can add 5 factorial plus 5 factorial. Okay. Yeah. So let us go to question number 11. Just don't do question number 10 right now. Go to question number 11. Okay. 8 chairs are numbered from 1 to 8. 2 women and 3 men wish to occupy 1 chair each. First, the women choose the chairs amongst the chair 1 to 4, and men occupy the chairs from the remaining. Find the total number of possible arrangements. Go through the problem once again. So these are the chairs. Okay. There are 2 women. First, the women choose the chairs from 1 to 4. So from 1 to 4, women, 2 women can sit anywhere. Okay. So woman number 1 can be seated in 4 ways because there are 4 seats. And woman number 2, 3 ways. Because if woman number is 1 is occupying seat number 2, there are 3 places left for the second woman. Okay. So there are 3 ways. right? Now see, for example, let the two women be occupied like this. Okay. Now there are three men. So first man, first male, M1. The male are going to occupy the remaining chairs. Okay. So male one can be seated in 1, 2, 3, 4, 5, 6 ways. Okay. Male 2 can be seated in 5 ways, and male 3 can be seated in 4 ways. There are only 3 men. Okay. For example, male 1 is sitting over here. So this place is occupied. He had 6 options, but then he went to 8th seat. Okay. Now for male 2, there are 5 options only available. Okay. Likewise. So you're going to multiply all this. 4 into 3 into 6 into 5 into 4. Let us verify the answer. 1440. Yes, that's correct. Fine. Yeah. Question number 12. You can actually do it on your own. It's pretty simple. Yeah. Question number 13. Find the number of arrangements of n distinct things taken R at a time in which three particular things must occur together. Now I have given you this formula in the formula list as well. Okay. Just a second. Yeah. If out of n objects, we are taking only R objects. Okay. 1 second. I'll just the formula was only for one object. Sorry. So question number 13. See. Uh, n distinct things taking R at a time in which three particular things must occur together. Okay. We'll continue with question number 14. Okay. Yeah. So how many words can be formed using all letters of the following words, using each letter exactly once? Okay. So first word cats. There are 4 objects and there will be 4 places for 4 objects. You can also do the box method. So 4p4, which is equal to 4 factorial ways. Yeah. Likewise, every subpart you can solve. Delhi, there will be 5 factorial. Jaipur, there will be 6 factorial. Hexagon, there will be 7 factorial. Okay. 15 sub question 1. So same word will take cats, the letters from the same word. Okay. But then this time we are supposed to take only 3 letters out of this 4 letters. So n is equal to 4, r is equal to 3, npr 4p3. That will be your answer. 4 objects and 3 places. Okay. Let's go to question number 6. 16. How many numbers consisting of 5 digits can be made out of the digits 1, 2, 3, 4 till 9 if the digits must be odd? Okay. First part, the number must be odd. Sorry. 1, 2, 3, 4, 5. So this will be occupied in 1, 3. 579. 5 ways. Now here, number of objects, n. I will make a object list. Okay. Just a second. So this will be 2468, 2468. So that is 4 ways plus. Now all 5 will not be utilized over here. Any one out of this 5 will be utilized. Okay. So 4 will remain. That 4, those 4 can be utilized over here. So this is 8 ways. This is 7 ways. This is 6 ways. And this is 5 ways. So the total will be 8 into 7 into 6 into 5 into 5. Okay. That will be your answer. Sub question 2. It's a 5-digit number. Okay. So the first number should be even. First 2 digits should be even. So this will be 2, 4, 6, or 8. 4 ways. This will be 3 ways because second digit is also even and one is already utilized. We have to use 5 different digits. Okay. Now this will be having what? 2 even digits which are underutilized till now plus 5 odd digits. Okay. 1, 3, 5, 7, 9. So this is equal to 7, 6, 5. So 4 into 3 into 7 into 6 into 5. Okay. So yes, the next question, that is question number 17. They're asking you to solve the same problem, 16th one, where the digits can be repeated. Okay, so 17, sub question 1, 5-digit number. Yeah, number must be odd. 1, 3, 5, 7, 9. So this will be 5 ways. Okay, this will be from 1 to 9 because repetition is allowed. So this is 9 ways, this is 9 ways, this is 9 ways, and this is 9 ways. Okay, everything is 1 to 9. Okay, you have to multiply all this, you'll get the answer. And second part, the first 2 digits are even and repetition is allowed. So I'll use this same thing over here. Second part, this is also 4 ways. First 2 digits are even. This will be 1 to 9, 9 ways, 9 ways, and 9 ways. So you just have to multiply this, you'll get the answer. So it is 4 into 4 into 9 into 9 into 9. 11,664. Okay. Yeah. Question number 18, you can do it on your own. And question number 19, actually we have done in exercise number 2. It's of the similar category. Okay, so question number 19 is similar to exercise number 2, question number 16. Okay, so then I'll leave it up to you. Thank you.